So we're going to talk about G&M codes today. You should make sure that you have your G&M code reference sheet open also as you watch this, and the notes, blank Google Doc notes that you're going to use to take notes. I'll give you some tips as to where you might want to write some things down. First of all, G&M codes operate CNC machines. That basic idea is something that you should know. So make sure that you do that. They began in the form of a punch tape. Less significant. You can see this would be really time consuming to punch all these through and have it run computers. Now it runs based off numbers and letters, and then the code computer interprets that. So it translates human language to machine language, and you type it into the computer. Again, just general knowledge, don't need to type that down. I'm going to suggest that you don't really add this to your notes because you can review this if you need to. But we're going to go through some sample program blocks. So please make sure you have your G&M code reference sheet open on the side so you can see what some of these things mean. Pause it if you need to try to find them. But here's a sample program block. You're always going to start with the block sequence number. It always is N. So every program line will have an N, and this is N1 because it's line 1. Then in this case, you have a miscellaneous code, and M06 will always mean tool change. So once you start to get used to these, you'll start to get used to what an M06 is. T1 is tool number 1. And then just like in Robot C, if you have a comment that you need to write, I believe in Robot C, you do it with a slash. Here it's with a semicolon. So a semicolon makes a comment that the computer won't read, and it's just a comment you can read, and that just says what it does. It says change to tool 1. Here's another sample block, line number N02. You notice there's a 0 in front of the 2. That's totally fine. You can have that. In fact, I would recommend that you always do that, because then when you get to 10, it's always talking 2-digit numbers. So N02, M03 is a turn spindle on. You are always going to have an M03 because you want to always have the spindle on. So before you have an S code, you need to have an M03. To turn the spindle on, S1500 will set the spindle to 1500. Here's another example, line number N03. Again, 0 is fine. G90 is a prep code, and that means absolute. G91, if you look at your reference sheet, says incremental, or it says relative. They both mean the same thing. And G90 is absolute. If you were using a piece of graph paper, which you will when you program out your yo-yo design, G90 uses the actual coordinates on the graph paper. So the center of the coordinate graph plane is 0, 0. If you want to move over a ½ an inch and up a ½ an inch, then you would type in x.5, y.5. So G90 just tells you use the actual coordinates on the graph paper. Relative or incremental is a little bit different, and I'll get to that later. So after G90, here we have a G01. G01 means move in a straight line interpolation. So that's all that means. It just tells it go in a straight line from wherever you are to the actual graph coordinate point, 0.5, 0.5, and the Z, your depth of 0. And we're going to go there at a feed rate of 1. So this is a really all-encompassing type line of code where you might move the spindle from one point to another point. So these are some things that you might want to add into your notes. You have address characters, and a character, it might be easier just to copy a line of code or type this line of code in and point to that N is a character, G is a character, F is a character. Those are all characters. You can see that the X, the Y, the Z, those would all be characters. So any letter before is a character. A parameter is something that is used to kind of define what the character is going to do, and those are all the numbers. So characters are the letters, parameters are the numbers. A word is the entire chunk. G90 is a word, X.5 is a word, F1 is a word. All of those as chunks, the underlying chunks are words, and then a block is the entire line of code. So those 4 sections would be important for you to know. We've seen those before in the final. So now I have the same sheet up as you do on your reference sheet. And remember, you can pause and rewind and review if you need to get some of that information again. But you should see most of these G codes in your reference sheet. G90 is absolute, G91 is relative or incremental. G00 means rapid traverse. This makes the milling machine run as fast as it possibly can from one point to another. G01 is move in a straight line with a certain feed speed. So after a G01, you'll have to have an F for feed speed. G02 tells you to go in a circle clockwise. G03 in a counterclockwise circle, and we typically don't use G04 or G05 dwell or wait, or sorry, dwell or pause, but you should note these because the Project Lead the Way final sometimes asks these. So let's talk about how to do arcs or circles. If you're going to do an arc in absolute, you might first move to the point 1, 1, or sorry, it looks like we're going to start at this point. You might first move to the point 1, 2. So here's our example. N0, so we're at the 0 line, very beginning. We're going to set it up to run in absolute coordinates, G90. And now our next line of code, do you notice they didn't do N1? You can put whatever number you want next for after N, as long as it's bigger than the first number. So they could have done N1, and they chose N5. And it's kind of nice to actually do this. I usually go by evens, because then if you miss a code that you want to insert something, then you have space. You could call something in here an N1, 2, 3, or 4 without having to renumber every single thing in here. So it is kind of a good idea to go maybe by even numbers or even by 5s or by 10s if you want. Now we're saying G01, so go to this point, x1, y2, in a straight line to x1, y2. So we move to that point. We really should have had a feed speed here so we could tell how fast it should go. But if we've defined a feed speed previous, then it just remembers that. So now we're at this point. We want to go to this point, x2, y1, but we want to go there in a circle. If we don't have a G02, it'll just draw a straight line here. But a G02 says go clockwise, and you also have to put the center of the circle. And so on your graph paper, you'll have to note, I want to go from this point to this point around this center. So we have G02 clockwise to that point x2, y1 around the center I1, J1. So we're going this direction around this center. So that's the entire line of code. Anytime you have a G02 or a G03, you have to have an I and a J to tell it where the center of the circle is. Now if we would have made this G03, that's going counterclockwise, it would have drawn all the way around like this, because it's still going to this point around the center. So that gives you kind of an idea of how you might make a curve. Now relative or incremental. Relative means go to the position that the coordinates say, but go there from wherever you previously were. So it just means go right 1 and go up 2. So no matter where we were, we're going to go right 1 and up 2. If we started at this spot right here, we would go right 1, up 2. So again, relative is from where you just were, where do you want me to go? And in this case, if we were at the beginning, we would go right 1 and up 2, which coincidentally is those actual coordinates. Now if we want to go to this position here, we're going right 1, down 1. So you can see the coordinates are x1, y, negative 1. So we're going right 1, down 1, and we're going around the center from this point of I, because I represents the x coordinate. We're going x no direction, but we're going y in the y direction, negative 1. So that's why we have an I of 0 and a j negative 1. Again, the I is the x version, x coordinate, and the j is the y coordinate. So this relative one is a little bit more tricky for some to understand, because again, you're going right 1, down 1, that's where we get the x1, y negative 1. But you're going about the center, right 0, down 1 from this point. There is another way to do arcs. You can do them with just a radius. So the only difference here is in absolute coordinates. We start at x1, y2, and then we go to x2, y1. So we're going into absolute coordinates, so we type in the actual coordinates of this point, and we're doing it with a radius 1. Now you got to be really careful with this, because if you want to make an arc that maybe is going from here down to here, you need to know where the center, or what the actual radius of that arc is going to be, because that's a really interesting, funky looking arc here, and the center is going to be somewhere at not a whole number coordinate. So those are much more complicated to do arcs that don't have nice whole number coordinates or whole number radiuses, in this case a radius of 1. If you did a radius of 2, then the radius would be down here, but this point would have to be way over here at x3, y0, and that would make a lot bigger radius of 2. Occasionally the program has issues with using R, but you can go ahead and give it a shot, and if it doesn't work, just call me over and we'll take a look at it. Using relative coordinates, again, we moved, starting from the origin, we moved right 1, up 2. So this does not stand for this coordinate position, it just means go to this spot from where you started. Go right 1, up 2. And we want to go to the point right 1, down 1 with a radius 1. So with R, it's the same thing. You just give it the radius. You don't actually have to put the actual position of the center. So sometimes it can be easier. Sometimes using the actual coordinates can be easier. You can kind of mess around with it and see. Some other common G codes. So again, looking at your reference sheet, you'll always need to put in a G20 so that it knows you're going in inches and not in millimeters. Really important. Otherwise, your design is going to be tiny. G80, 81, and 82 are canceling the cycle, setting up a drilling cycle, and a drilling cycle with dwell. We never end up using the G80, 81, and 82. So you might want to just, you don't even need to note these, but just maybe review these before the end of the year final. And then M codes, really important M codes that we use. An M00 as a pause, we typically don't do because we want it to just go from start to finish and then be done. We don't really use the optional stop. You will always end the program with M02. That stops everything. It should be the very, very last line of code. Near the beginning of the code, you have an MO3 to turn the spindle on. And what goes after an MO3? Do you remember what that code was? Should be an S something for the spindle speed. So MO3, S 3000, whatever the spindle speed is. At the end of your code, before the MO2, you're going to have an MO5, turn the spindle off. We don't ever use a tool change. We rarely do an MO6 because that stops the code. It lifts the milling bit really, really high, and then it allows you to kind of change it, and then you manually have to click start again. So we don't ever use a tool change. That's a question that you'll often see on the final. MO8 and MO9, M10 and M11. Do you remember in the previous video where we showed the pneumatic clamp? You can actually code in, if you type MO8, and it will manually clamp the piece together. So there are situations where you want to do that. If you are connecting with a robotic arm and you want to have it do talking to each other, you put a part down, you want it to automatically clamp the part into place, begin milling it. So there are situations where we've used those. Pretty advanced. You won't be using any of these unless you get into advanced stuff. And then M30 if you want to end and reset the program, or M47 to rewind it. So again, if you're trying to use another robot to communicate and you want the code to repeat, then you would use an M47 to rewind, and M30 will just end it and reset it, maybe if you're checking for an error. So some code suggestions. Same code is not required to be repeated on every single block. So if you set an F, a feed speed, on the first block, as long as that feed speed is the same for the next few lines of code, you don't have to rewrite it again. Tab remarks away from code to facilitate troubleshooting program. So after your semicolon, if you push the tab button and kind of slide them all over, it does help with comments. You always need to specify absolute or relative coordinates and inch or metric units, so always give a G90 or a G91 at the beginning. And we're not really going to do tool change, so we don't need to really be concerned with this. Spindle speed should always be indicated, so after an MO3 you need to have an S. You need to move your tool to start position in 2 lines. So first you would move it in the XY plane and then in the Z. You don't ever want to go diagonally down into something because we have good bits that we don't have to worry about them breaking. So go left and right and then plunge. And this prevents the ramping or cutting the part or cutting into the clamp, which is really kind of a freakish, scary thing when that happens. Always raise the tool out of the stock at the end of the program. So at the end you would type in maybe Z going up 3 inches. Just get it way out of there. Makes it really easy to get your block out of the way. Always move the table to a safe position, and I'll talk about that in a code later. And then end with MO2. So in the next video series, I'm going to walk you through how to actually code the absolute parts and relative parts.